Okay, can you also see me?
Yeah, I can see your video, but
I will use this. Yes.
Okay, is it really important to that you
Oh, no.
that you share your camera? Because I'm sorry, but we are not Netflix. Okay, we have some issues with video, and it's maybe clearer if you not activate your camera during your presentation.
Okay. Yeah. That works. Yeah. Now it's fine, right? Like,
Yeah,
I can see.
it's perfect. Yeah,
Okay,
and
cool.
we can hear you, so you can start when you want.
Okay, sure. All right, I'll start my presentation. Hi, everyone. My name is Tejas Chopra, and today I'll be presenting cloud microservices for the next billion users. Um, okay, yeah. The way we'll go about this is I'll set up the agenda first. Uh, I'll begin by introducing myself and my topic, and then we'll go into problem space definition. Exactly what do I mean by cloud microservices for the billion users? We'll define requirements and how we were ideating a solution. We'll pick some design choices that I picked while developing these microservices based architecture, and how agile and iterative development helped get to the goal. Finally, I will go into what were some of my takeaways and learnings from this experience. And here you can see a picture which shows a very typical retail store in India. These are small mom and pop stores or small and medium businesses that are like dotted around in villages, cities, and towns of India. And there are like 12 million of those spread across the country. People go here typically to buy food or daily consumables. So, what my topic covers today is how we try to disrupt this system. Let me first start by introducing myself. My name is Tejas Chopra. I am a senior software engineer at Netflix. And I'll cover my journey. Um, in the year 2010, I came here to the US from India, and I did my master's in electrical and computer engineering from Carnegie Mellon University in Pittsburgh in US. I have a specialization in computer systems. From 2012 to 2016, I worked at Apple and Samsung, where I was working mostly on distributed systems. In the year 2016, I joined a startup where I was the first hire. It was trying to disrupt the space that I just talked about by creating an Amazon like marketplace for fast moving consumer goods. And I'll explain what exactly that means. The goal was to build software for the masses. It is this journey that I'm capturing in this session. After 2017, I joined Datrium and then Box, where again I was working on distributed file systems, storage, replication, cloud storage, all the variants of it. And finally, in 2020, I joined Netflix. My job in Netflix is to develop storage infrastructure for Netflix studios and Netflix streaming. The amount of content that is generated by these two verticals of Netflix, how to store it efficiently, how to retrieve it efficiently, all of that is something that I do here at Netflix. Let us first begin by why exactly are we talking about all of this and what is the problem that we were trying to solve here? Got a question. Okay. Um, so when I talk about FMCG, these are fast moving consumer goods. They are packaged goods, beverages, toiletries, cosmetics, food, and other consumables that you consume in your day-to-day life. A lot of them are perishable. Here is a diagram, like a photo of what you can consider as FMCG. You see that there are a lot of chips and like stuff that you consume every day, chocolates, etc. Um, in the US, there are huge malls like Macy's and Target where people buy these. But in India, there are small mom and pop stores where people generally go and buy this stuff. It's a $50 billion plus industry in India. And the way this model works is you have wholesale traders on the one end and retail shop owners on the other end. There are 0.33 million of wholesale traders and there are 12 million retail shop owners. And these 12 million retail shop owners serve a population of more than a billion users. So by disrupting this space, you affect the life of these billion plus users. That's why whatever we are building, we know that the impact would be on the market, the entire like billion plus users market. The problems in this domain are there is a lot of wastage in the last mile between the wholesale traders and the retail shop owners. It is actually 70 tons of food per year. And there are several reasons why there is this wastage. First of all, the last mile delivery is very untimely because shipping between the wholesale trader and the retail shop owner is handled by the wholesale traders sometimes. It is very untimely, very mismanaged, and that results in a lot of food just expiring before it reaches the retail shop owners or close to expiry. So that's really throwaway. You cannot really do anything with perishable items. Second is there is no feedback mechanism today when let's say someone bought some food or some stuff from a store, and if that food is bad, they will talk to the shopkeeper and tell that this food is bad, but there is no way for the retail store owner to give that information back to the wholesale trader, that is his supplier. So that loop doesn't complete today. um, Thirdly, there is no catalog or inventory log maintained by the stores today. So there is no technical way to maintain. They just use pen and paper and keep track of what is there in their store today. Um, and last but not the least, they have deeply entrenched relationships. Typically, a store owner will just talk to one wholesale trader for the entire life cycle of the store. So they will not know if there are other wholesale traders that have better deals or not. You can think of it like in Amazon, if you're selling something, and if I'm a buyer, if I only know one seller and I don't have the choice of choosing from different sellers, it'll just make my life so much more difficult. So these are some of the problems that exist in this FMCG market space. Here is a picture of a typical wholesale store. As you can see, it is highly mismanaged. There are a lot of variables here that you can't keep track of. There is no inventory management. So this is the market that we want to disrupt. What if we could prevent this food loss or make a dent into it? What if we could create a marketplace just like Amazon for this FMCG products? Here, the buyers would be retail shop owners and the sellers would be wholesale traders. So it's a B2B marketplace. What it does is it gives buyers a choice and sellers a platform. Choice is always good because you can then, if you don't like a particular seller, you can work with another seller and you can compare their prices, their quality, etc. There is a feedback mechanism. You can have ratings embedded into your marketplace, and that will allow you to pick a seller when you're buying something. Very important, ability to search and seek offers. So whenever you order something in bulk in Amazon as well today, you get amortized cost of shipping, or you get some offers that are there. In the real world, that is generally done by relationship management. But this makes it this embeds this in the technical app. So ability to do that is what this platform will expose. And what at the end of it, what we want to do is we want to build something that shows empathy for customers and for small and medium businesses. And I'll get into why I'm talking about empathy here. Firstly, when we started looking at this, right, we came across a lot of challenges. The customers for whom we were building this platform, they have never used a smartphone. So today you're so well versed with how an application works, how Amazon works. You start Amazon, you have to log in, you know the concept of a cart or a product, but for them they don't know how to use a smartphone. So a lot of the challenges stemmed from teaching them how to navigate their way around a smartphone. They are very concerned about the battery lives of their phone because they work on razor thin margins. Battery life is such a critical component for them that they really want to squeeze the maximum out of their phone. A lot of the products that are there in the market, they use English as the means of communication. So the product name or the explanation is written in English. A lot of our customers were not very well versed with English, so they needed something that is more local. So how could you translate all the embedded stuff into local language was another challenge. The idea of a cart, the notion that you can put stuff in a cart and then order it, or you can look at your previous orders, or you can look at where the shipment is at this point. All of that was not something. It was not something that was very common amongst our customers, so they were not aware of this. And finally, uh, we when we look at a product like an iPhone or something, we read about it and we try to understand what that product is, or what its features are. But for a lot of customers, they understand a product just from the images, not from the content that is written on the packets. And so it was very important to design a user experience that like enlarges the product images but reduces the size of the fonts and whatever content is written there. So these are some of the learnings that we took from our interactions with our customers, and that helped us define our requirements for this platform or this marketplace. Look at Amazon, and you can then see what are some of the table stakes for a marketplace. You need an ability to search for a product. You want to look at different images of the product, different variants. Someone had a question here. Uh, what about the cost of data usage for users? Yes, so that's a very good point. I think is network infrastructure in general was very poor at some of these places. So when we first came out with our product, what we did was we provided smartphones and we took the hit on the data usage, so that we can learn their patterns. And I'll get into how we optimize that as well. Uh, so product search is one of the key features of a marketplace. Order management system, an ability to add items to a cart, place and track orders, and view your history. Authentication, when you log in, you need to have some form of notification or OTP or some message that authenticates you. Offers, the ability to look at offers and to provide offers to users so that they can order in bulk. And finally, this is just one end of the spectrum where we have buyers, but we also need an ability for sellers to ingest their products and offers into our system. So we need to create a seller portal as well. Um, so these are some of the things that we really need to build. And here comes the initial design choices when we bootstrapped the solution. We picked cloud as the way to go for it. AWS was the natural choice back in 2016. It had 80% of the market share. It allows you to build cloud native services. It gives you elasticity, security, manageability, and it is ideal for bootstrapping an idea because it just provides you so many, like they provide you credits and stuff that you can use to just start building services. We relied on DynamoDB. So DynamoDB is a NoSQL database, and maintained by Amazon, that had enough throughput for reads and writes to serve our needs. Initially, when I entered into this domain, I did not know the structure of the data. Products can come with so many different attributes and variables. So because the data was unstructured initially, we went with DynamoDB, and we had tables for products, orders, notifications, shipments, etc. Amazon also provides a Kafka-like event like handling system where you have producers and consumers, which they call Kinesis. And we use that to to have asynchronous workflows that populate several tables. And it is used, for example, when the seller updates the product image, you want that image to reflect on the app and to be seen by the buyer. So all of those kind of async workflows were handled by Kinesis. Redshift. So Redshift is a data warehouse exposed by Amazon again. And what data warehouse does is it's just a dump of all the data that or insights or metrics that you want to collect. So whenever a user is scrolling on an app or clicking something, even if they don't buy it, you want to capture that so that you can make your user experience better, or you can infer insights from user behavior. For example, let's say in the month of December, people were looking at buying more chocolates because it's Christmas. So that behavior was captured by Redshift and the insights that were built on top of Redshift. And that informs the sellers of what their inventory management system should be like, so that they can like either have more chocolates at their disposal or whatever. Yeah. Given that we have these set of requirements, right? How do you now start bootstrap creating this marketplace? So we used agile development practices, which means that you design iteratively. What this does is it gives you it provides you the ability to seek feedback immediately, incorporate in your product, and you can slowly build upon your previous iterations. We started off with a pilot first. What was the pilot? It was a simple SMS-based solution. So what that meant is every morning we would send an SMS out to our buyers, and the SMS would contain a list of all the products and their quantities that are available. The buyer who did not have a smartphone earlier, can still use their feature phones to look at this SMS, and they would physically type in what product they wanted and how much quantity they wanted. So the way we did that was, I think there was a question. How do you make it fit into the into an SMS? Yes, that's a good question. So earlier we had very few stores that were buying, and we had only one wholesale trader. So we just attacked a small vertical of the products, not all the products. So let's say chocolates. So we just used to send an SMS that contained information about chocolate names and images, and the SMS had a limit, so there were multiple SMSs actually sent, and very poor user experience, as you can tell. But what that meant is the users could at least have a way to look at these, and they got a feel for what a product image is, what quantity is, and how to place orders. And the way we built that is we used AWS Lambda. Lambda is a function as a service, which means that you do not own a machine. But let's say you want to just run a function, sending an SMS. You program the function and then you give it to Lambda, and Lambda will pick a random machine on the backend that you don't know and you're not aware of and you do not manage, and it will run the function at the designated hour. That's what Lambda does. And it's picking up a lot of pace because this is the basis of serverless, where you do not own a server. So we use Lambdas to send this SMS every morning. And this only went up to 10 stores. So it was not a very scalable solution. Every evening, there would be a human who would collect all these responses from from the buyers, collate them, and then provide that information to the sellers. As you can see, it is very manual, uh, very requires a lot of vetting of responses, reaching out to the buyers again to confirm, etc. What we saw was Lambda works great for timed delivery of messages. Human vetting is painful, and it must be replaced by programs. This approach is very rigid. It has no offers, it has no real-time quantity updates, and it doesn't provide a great user experience. But what it did do is it did not require a lot of network. It did not require a lot of data usage. And we saw that even by this trivial pilot, there was a huge surge in orders, and we were doing $500 per day revenue. Of course, we had to move on to the next stage after the pilot. And for the first iterative development for the first one, what we did is we started with having a Lambda and having an EC2 instance where our services are running. So we split the seller portal separate from the buyers, which is the Android app. And the call would come to an API gateway, and it would split into seller portal APIs and app APIs. The application APIs would go to a Lambda, and the seller portal calls would go to an EC2 instance that is running one monolithic service. We would invoke the Lambda on every order. So every time a user tried to place an order, a Lambda function would execute, which would try to then mutate the DynamoDB tables where we store all the orders, products, and invoice information, and update the quantity there. A very simplistic interface, and it works great for less than 500 orders per day. And the problem with this approach is that Lambda has a very slow warm-up time. So when you place an order, it took a lot of seconds before you could get the order confirmation. And that is very poor user experience. But it is better than just getting out an SMS, right? And it works great for small amount of orders. And it was satisfying our need for some time. Then we decided to remove Lambdas and instead replace it with monolithic services. What a monolithic service is that you create a service and you put all the functionality into that service. That service will interact with different databases, different tables, have different business logic for order flow, for product information, etc., authentication and all. So that was the first step that we took. And like I said, it contains information about products, order management system, notification, and there was a monolithic service for the sellers as well. The framework we used to develop these services is Drop Wizard framework, and I'll get into what Drop Wizard is. This worked well because now we've moved away from Lambda, so we do not have the slow warm-up time now. Order placement was very quick, but this does not give us any browse or search ability. So what the interface of the app was that users had to just scroll through all the products and then place an order. And order placement was also interesting. There was no concept of a cart at this point. So just like you do with, Tinder or something today, where you just swipe right and it's a yes, or swipe left and it's a no. In the same way, we just allowed swipe of single swipe where people could just swipe and place the order. And this worked great because that was very quick to do um, for the users. And we saw, again, a surge in orders as soon as we rolled this feature out. Uh, what the problems that existed here were that there was no localization. So we did not invest at this point yet in trying to convert the English language into different localized languages and change the images. Okay, there was another question here by Leo. How do you manage quantity then? Uh, oh, about swipe. Yes. So that's good point. So you actually enter the quantity and then you swipe. So it's it's it was easy enough for them to enter that quantity because they were used to it using SMS and lambdas. So they already knew how to do it. But then the swipe was a new thing that we provided them, and they actually leveraged it a lot. Um, The other thing to note is when you look at an iPhone, right? And we'll get into more details about this. When you look at an iPhone, you know that the manufacturer is Apple. It's a smartphone, and it has iOS. So all of these are attributes of the product. And when you search for a product on your app, you can search by any attribute. You can search by give me all the iPhones that have been produced by Apple, or give me all the phones that have iOS, which will by default be Apple iPhones. So there are different attributes by which you can search products or browse through products. That means that there are several relationships that are built between products and their attributes that allow you to just do that particular search. In this model that we have right now, we do not have any relationships built in. So there was no easy way to go from one product to the manufacturer of the same product and to another product by the same manufacturer. So those are things that we learned after our interactions with our customers, and that is what we wanted to build next. We realized that monolithic services only scale so much. So we had to break our monolithic service into a bunch of microservices. Monolithic services are difficult to scale, modify, test, and release. And there is a lot of business logic that touches different tables. So what you want to do is you want to ideally split your big, massive service into smaller microservices. Product could be a microservice on its own. Cart and order management could be a microservice. Notification is a separate microservice, etc. But there is also a problem. There is a curse of too many microservices, which I've seen at many places in my career, where uh, in order to go into microservices, people just create very, very tiny microservices that just interact with one table. What that means is it increases the latency between intra-service calls. So what you ideally want to do is have a very fine balance between too few services and too many services. And the way you can do that is understanding the behavior of the services and grouping different functions into a single service. So if there are different functions, like for example, cart and order management can work together because they are tied together functionally and they scale together. So if you have more people using cart, there is a probability that there'll be more orders. So those determine how you want to club different services or functionalities together. So that was first, like we split it into microservices, but you also see that there's a lot more that goes on after DynamoDB. And what exactly is that? Um, when the seller updates a product, let's say the quantity or the image of the product or an offer, you want it to be reflected quickly on the app, and you do that through asynchronous workflows. And for that, we used Amazon Kinesis. Amazon Kinesis is this service that is provided by Amazon, which is similar to Kafka, where any update made to a DynamoDB table can be a producer of an event that is consumed by this Kinesis, and there will be many consumers of this event. And you can design these different consumers that can read from Kinesis. And these are different adapters and indexers that we created. Now let us get into what these indexers were. So catalog indexer is when a seller updates the quantity of a product and you want it to reflect on the app. So you would read the DynamoDB table change and then send it to this indexer, which was a Lambda. And it would then reflect it on the app. There's a Redshift Indexer, which means that whenever the users interacted with an app or clicked or pressed anything on the app, we would consume that information, pass it to this Redshift Indexer, and that would index the Redshift, the data warehouse that we have. And finally, we have the Elasticsearch Indexer. What this does is, like I explained, when you insert a product or ingest a product into our system, you want it to be searchable and indexable, and that's why you want it to be searchable by the manufacturer or by the brand. And this Elasticsearch Indexer creates this search index for us so that the users can then search and browse products. And I said that I will talk about Drop Wizard. So Drop Wizard is a very good framework for developing cloud native microservices. You can think of it as similar to Spring Boot, and we could have picked anything at that point. I just happened to do a quick Google search and Drop Wizard showed above Spring Boot, so I just picked Drop Wizard initially. It gives you frameworks such as Jackson, Jetty, Jersey, and Metrics. These are different libraries. Jetty embeds an HTTP server inside your main method. Uh, Jersey maps your REST requests to Java objects. Jackson is for JSON serialization and deserialization. And if you look at this example, right, it's very simple to create a Hello World service here with Drop Wizard. And you may see it may seem very similar to Spring Boot as well, because here you specify the path of the resource and what exactly is the REST response, what it produces. It's a JSON response. And you can just have a query param passed into the function. It's a get function. You can have annotations that can time the amount of time taken to execute this function. So this is a very simple way to start with microservices on cloud. All you need to do is create a resource class. Metrics and health check come by default in a Drop Wizard. And you can configure health check to see if your instances are up and running, or if you can just ping some other services and check the network, etc. We could have used Spring Boot too, with which dependency injection comes built in. So that was something that we could have done. It's just a choice that we took. And finally, like I mentioned this very briefly, that the products that we were selling had different attributes. And let me get into what exactly these attributes were so that you can understand the complexity of what we are building. This is all the products that are sold by Procter and Gamble, which is a very well-known seller of different products. If you look at these, there are these different verticals. These are the different product verticals. That term, you can see hair, grooming, personal health care, baby, feminine care. All of these are different verticals for a product. And there is a product line. What product line is let's say Pampers diapers are a product line. Uh, and Tide wash for your clothes is a product line. Um, Products would be entities within this product line. So there'll be so many types of pamper diapers that there'll be different sizes. There will be different, like I could say, qualities of diapers also. And So they form different products in that product line. So as you see, you have a manufacturer, you have a brand, you have a product vertical, you have a product line, and finally you have a product. And these relationships are very tricky to manage because sometimes a manufacturer just has products. Sometimes a manufacturer has brands and the brands have products. Manufacturer having brands, the brands having a product vertical and they have products. So instead of a tree, it is a graph of product attributes. And that adds to the complexity of how do you design search and browse for a graph. Um, and I get here, like it has dynamic relationships, and these relationships are interesting because for some of the products a lot of this information is missing. So you may think that Procter and Gamble is a manufacturer, but it's not just a manufacturer, it is also a brand for some products. So it's very difficult to gauge these relationships, and we want to give ability to search products by manufacturers, brands, or product verticals. A sample API would be, give me all the products where the manufacturer ID is 1234 and my brand is 5678, or products for which the product vertical is ABCD. So how do you design a database or the backend for such a graph? And unfortunately, the way I did it was, which was wrong, was I embedded secondary indexes in different tables. So in the product table, I would have product vertical ID, product line ID, brand ID, and manufacturer ID embedded. So if anyone wanted to search for products that belong to a particular manufacturer, I would just have like indexing done on the secondary index of manufacturer ID and get all the products. Uh, what that meant is whenever someone ingested a product or changed a product, I would have to design indexers that would read that change and then index different tables, manufacturer tables or brand tables, etc. And that adds a lot of code and complexity into the system. Um, and I'll explain how. So this is how the model that I went with, and it worked great. But this was in 2016. And with hindsight, I know what I could have done differently, and I'll get into that. So at this juncture, what was the state of our application? We have a buyer app that has product search and browse. You could place objects in a cart and order. And you had an order management system where you could generate shipments and invoices, and you could look at your order history. We had a seller platform where sellers could ingest new products, they could update quantities, they can update offers, and you can get orders that the customers have placed, generate invoices and shipments out of it. So at this point, like that's the point where the state of our app was when I moved on. And here are some of my the takeaways and learnings that I had from this experience of building microservices. There were a bunch of technical learnings and product learnings. Let me first get into technical learnings. Uh, DynamoDB is not the best database for relationships, like I said. I should have used a graph database. So what graph database does is it is built for problems that I just mentioned, where there are relationships between entities, and the relationship is very important. So a product having a manufacturer having many products under it, all of that can be easily modeled using graph databases, and you do not need to write complicated queries to search. It doesn't do a scan and secondary indexing to search for all of these results. Amazon Neptune is a very good example of a graph database that Amazon has. There is Neo4j as well. And I could have just used Amazon Neptune or Neo4j that is backed by DynamoDB. Uh, it would still leverage the event streams of DynamoDB, and it just makes my job so much easier because I do not need to have indexers downstream to index manufacturers, brands, etc. Um, Second is Kinesis. So I used Kinesis because it was easy. It was available by Amazon by default with DynamoDB, and it was a one-click enabling of the streams. But Kafka, compared to Kinesis, is faster. It allows for faster retrieve. It allows for longer periods of data storage. Kinesis, at least back then, would just allow 7 days of storage of your events. But Kafka, you can configure. And Kafka back then did not have connectors for DynamoDB or Redshift. So it was more difficult to write those. But today, Kafka has a lot of connectors for both producers and consumers. So it is very easy to put that in. The only problem is it will be managed by us. So you need to be aware of scaling the Kafka cluster or looking into the Zookeeper to see if it's up and running. And finally, containerization. So till now, all the services that I mentioned, they were separate EC2 instances. But that's not how you want to write your microservices. You want to write containers today that can be managed by Kubernetes for you. So if your instance goes down, or if one of the containers goes down, one of your pods goes down, you can easily spin up another pod automatically. That's where the world is moving, and that's where you should build your microservices, that platform. So that's something that I would have explored in today's world. um, CI/CD pipelines. So continuous integration and continuous delivery is very critical if you want to build agile software, and I would have integrated that in my development lifecycle. um, Also, one important thing that comes with containers is intra-service calls. Today, you make REST API calls from one service to another, but there is an ability to create a service mesh, which is just like Envoy or HA proxy, that allows these intra-service calls with authentication, metrics, and other things. And it's an infrastructure that is heavily being used by companies today, like Netflix, like Box. So that is something that I would have used in developing these services. Product learnings and takeaways. What we saw is, by allowing people to swipe right, that interface, what was happening is people were just doing that and they were not understanding the concept of a cart. In a cart, you add orders and then you for during the day, and then you figure out a time when you want to place the order. And that was not happening for our customers. So what we did is, instead of making them change their behavior, we changed our software on the backend. What we would do is, whenever they placed an order, whenever they swiped right to place an order, we would just put it in a virtual cart on the backend. We would update the order quantities right away. But what that meant is, we could develop cart management system on the backend. Um, and the reason why we wanted a cart was because bulk orders reduce your shipping costs. So we wanted to give those savings back to our customers. And by doing this particular virtual cart mechanism, we reduced the shipping costs for the customers by 27%. By providing searchability and browsability, we increased orders by 24%. Like I said, a lot of products have missing data. Some of them did not have a brand or a manufacturer. What was important to know is, for each product, we had to do research to find what is the best way to show this or a collection of these products to the user. Some products were better off when being shown with products that belong to the similar product vertical, whereas some others needed products with a similar brand. For this, we had to interact a lot with our customers and understand their behavior, because they have a deeper understanding of this market. So that research paid off, and it caused an increase in our orders. And by generating insights into customer behavior and using Redshift, we were able to increase our revenue by 34%. Um, and how do we know this? Like, the way we track this is, users were when they scroll in an app or when they like browse different products, we would capture those metrics and we would relay that to our sellers, and the sellers had offers that could bundle these together. And when the customers would place this order later, that's what we would capture, and we would see that that has led to an increase. The only side effect of it was our cloud costs exploded. So because Redshift back then was very expensive, we went from $500 per month for Redshift to $4,500 per month in a matter of 3 months. So those are some of the things that you have to balance when developing these services. The results of this. So these are results in the first 6 months that I captured. Our wholesale traders, which were the sellers, they increased from 1 to 7. Our retail shop owners, our buyers, increased from 10 to 400, and they were touching a bigger market of like around 4 million people. The insights, which is the data that is captured in Redshift, increased from 7,000 data points per day to 780,000 data points per day. Our revenue increased from $200 per day to $8,000 per day. And finally, what that led to is an efficiency improvement of 27%. So we were able to save 27% of food or perishable items from getting wasted by using this particular marketplace. And the reason I show this as incomplete is because there was still much work to be done here, and services to be built to improve the efficiency even further. As an engineer, what are my takeaways from this experience that I had? First and foremost, you build software for the customer. You need to understand the behavior of the customer, what they like, what they understand, and show empathy. And it should permeate in all the services that you build and the user experience that you build. A very good example of this was the localization part of it. We knew that our customers would be uncomfortable with just having product images in English. So we invested our energy and money in trying to build images and curate them and put out in languages that the customers would like to look at. So that is one thing that I take away, and something that I am very cognizant of in different companies that I'm working after this experience. More code is more bugs. There is a common adage that there is a bug every 100 lines of code. So how do you have lesser bugs? You just write less code. And you have to write simple code, not too convoluted or complicated code. If you have an array of 10 elements, you do not need to have a very complicated search or sort like algorithm built on top of it. You can just iterate and do like search for something. So I think these come from different learnings and experiences. So that's something that I take away from it. Pains of scale. Um, Things work when when it's just a few users. As soon as you increase the number of users, your database throughput increases. And there are a lot of checks and balances that AWS has to prevent you from increasing the number of reads or writes that you do to the database. So those are things that will come out only when you scale. And that leads to poor user experience. So you need to be very cognizant of how you want to scale. What one thing to note is it's okay to fail, but you have to not lose data. So at any point of time, it's okay to return to the user that sorry, we can't place your order right now. But like once they've placed the order, you cannot like undo that because they've already like committed to it. So things like such as these were my learnings. Performance on smartphones. So smartphones, if you design something incorrectly, you can hog a lot of the network and battery life on smartphones. So the way we try to tackle it is we did a lot of caching of the images on the user's phone, which is very common technique used these days. We used compression as a technique to compress the amount of data that is sent over the network. We were also exploring, instead of using REST APIs, using GraphQL, which only gives you back a subset of the data that you request. With REST responses, with REST APIs, you make a request to the server, you get back a big response, and then you filter out the response on the client side, or you do something on the server side to just return appropriate fields. GraphQL makes this easier to do. Um, Invest in learning about the business. As a software engineer, it's very likely that I just try to trade focus for just focus time for learning a lot about the business, which means that I would rather spend my time on my problem than trying to understand where it fits in the larger scheme of things. This may help initially to solve the problem, but if you really want to build solutions for the business, you need to understand about the business problems and the pain points and see where tech can come in and solve them. Um, for example, we realized that our customers did not have a good way to track inventory. They were just using pen and paper to track how many products they have in their store. But by using our app, they could know whatever orders they've placed, and that would be a very good way to track inventory. So we built something on top of it to give them an ability to track inventory easily. Now, this was something that was orthogonal to our app, but we did it because we wanted our customers to not have that pain point. Final learning. Data is gold. You must always invest from the get-go to invest to build a mechanism to get insights from data. And that cannot be done later. It should be a part of bootstrapping itself. Cloud costs will spiral out of hand. So if you've designed your services in a way that use a lot of network costs or use a lot of storage on S3, it will quickly spiral, and you will be left thinking, what can I do to fix it? So you should try to see if you can have a mix of cloud and on-premise hardware as well in case of storage, and reduce the amount of footprint that you have on the cloud. That's my time. I hope that I was able to give a brief snippet into my experience at that company. And here is my contact details if you want to reach out to me or just like comment on this session. And now I'm ready to take any questions if you may have any. Uh, I haven't actually heard about Kai OS, Leo. So could you give me some more details on that?
Leo, don't hesitate to activate your camera and your mic to discuss with Tejas.
Hi Tejas, this is Leo. Actually, I cannot activate my camera because I am in Madagascar and I'm having an electrical issue right now, so I'm in the dark.
Okay.
So KOS is basically an OS for smart features phones, which is known to be to have become the second OS in India.
Okay.
Yep, actually, it's an OS designed for low incomes users. So it basically has the same functionalities as a smartphone, but for
interesting.
user who cannot afford even the
Yeah.
cheapest smartphones.
Oh, that is awesome because back then in 2016 when we were doing this, we did not know of this OS, and this is really great because what this means is in the future, if we have to build such a marketplace, this would be such a great entry point for us. And back then it was only Android and iOS phones. iPhones are very expensive. Android phones were cheaper, so we thought we'll just go with Android apps and Android phones. But this is a great thing that I take away from this. So thank you for this. Yeah.
Okay. Do we have any more any more question? Okay, if not, I have one for you, Tejas.
Yes.
You speak about to get insight from the customers, and do you catch all this insight only from data, or maybe with some special user dedicated and evolve into this program?
So initially we started with just talking to users, getting their feedback. So it gave us some idea, but it was only driven by data because as you scale, you will get users of different types, and data would be the place that you would want to get back to. So, for example, we saw that users bought rice and wheat together. Now, those are things that you will just know from data, and sometimes users themselves don't know that they buy it together. And they were really actionable insights because it could tell you how much inventory the sellers could have beforehand. And but yeah, it was a mix of both initially, but then it tended towards only data towards the end.
Okay, and how could you manage the right data to analyze? Because I think it's maybe I don't know how to start. Okay, when you collect data, we can collect everything, and just after make some studies and some data engineering activity in order to see, okay, this kind of data is really relevant for us. But
yes, yeah. So the way we did it is So again, like in everything that we were doing, it was iterative. So we first started with items that the users were just browsing and they clicked, but they did not order. So that was the first thing. Like they clicked and they looked at the product images, but they did not order. That means that there was an interest in learning about it. So those were the products that we looked at, and we saw that are many users looking at the same kind of products in the same product vertical, which means that, for example, if it's the monsoon season or if it's summer, ice creams and stuff would be products that they looked at. But why did they not move ahead with it? Is it that our costs were not good? Did we not have the appropriate products out there? So those were things that we then reached out to the customers to learn from them initially. And then when we had many wholesale traders on our platform, they would compare products between wholesale traders. So that means that they were either comparing the cost or the offers. So those were insights that we started off with. Once we did that, then we went into once we had the relationships, we went into do customers click on brands more than manufacturers for a product? So that told us that for, let's say, chocolates, they cared about the brand rather than the manufacturer, or they cared about the product vertical rather than the brand. So those again were insights that helped us show similar products using those attributes. So yeah, it was an iterative process, more than one, like just dumping it everywhere. And we wanted to also be cognizant of the cloud costs, because costs will spiral out so quickly with Redshift. So we did not want to like just pay so much, because we were a startup back then. Yeah.
Okay, it's more clear for me. But when I heard to you, it seems so simple. But when I come back to my experience, I say, how could it be so complex? Okay, in order to catch the right data, to make some hypotheses and to verify them. And
yes,
okay, I'll take this reflection for me. Thanks, Tejas.
Yes. Anyone else has any questions? Does that mean that you trigger a microservice on each user action, or you have another way to get this information? Okay, so it means that what we do is we piggyback on a lot of information. So when a product is browsing it, the insights were captured on the phone, and then we had a batch of various insights sent in one REST call. Instead of making a call for every data point, we just would have like thousands of data points in one call. And yes, there was so there were several microservices that we had. This was one of them. And its job was just to get this REST call and dump this into Redshift. So yes.
Okay, excuse me, Tejas. I'm switching on my mic again. But actually, I'm quite interested with your use case and the whole project that you described, because I live in Madagascar as of now, and I have a few more questions about the product itself, more than the tech aspect. So forgive me for that.
Yes.
Actually, how do you manage to well? Just let me describe you the retail networks in Madagascar. Well, you don't have so many providers, like, for example, for beer, there is only one company in the country. For biscuits, there is only one company in the country that distributes biscuits all over the country. So how can you start a business like that if you don't have at least the proof of concept contract with one of the major companies in the country? How did you start it at first?
Yes. So we had, and with Amazon as well, it was the same. So you start off with having one wholesale trader, and I'm sure that that biscuit company is selling their biscuits in bulk quantities to some sellers, and then the sellers are selling it to some other sellers, and then it permeates down to the population. So there'll be many levels. I think it'll not be just the biscuit company selling to you and me. There'll be many intermediaries in the middle. So what we did was, we know that, for example, Procter and Gamble produces so many things, but they sell it to some particular wholesale traders, and we tried to interact with them. We also created a wholesale entity of our own. which would then buy from Procter and Gamble and then sell it to the retail shop owners. So we actually created the first wholesale entity ourselves, and then we got other wholesale traders onto our platform. So that was how we bootstrapped first. Does
Okay,
that
okay,
answer your
that's
question? Yeah, yeah,
perfectly. That's a major point because here everything is three level: the producer, the retail, the wholesale, and then retailers. Yeah. So
yeah,
you
yeah.
have to create first to register yourself
Yes,
as a retail as a wholesaler.
yes, that's correct.
Okay.
I think you're muted.
No,
Thanks.
I
Yeah.
just muted myself, but I have another question coming up.
Sure.
What was the reaction on the market from other resellers, wholesalers? Sorry.
I mean, they initially they did not like it, because we were eating into their business. But then they became a participant in our business, and they realized that their reach can be increased by just being on our platform. Like earlier, a wholesale trader would sell to just the nearby places where they could send a truck or a shipment to. But we handled the shipment for them. So now they can reach multiple places. And we also allow them insights into data, which they would not have gotten otherwise. And people don't realize, but in many businesses, data is very important. Almost all businesses, data is important, but there is no structured way of getting it. So when they saw the value in that, and what matters for them at the end is how much money they make. So when they saw that by being on our platform, they made more money, it was a natural choice for them. And one wholesale, they have very close relationships. So one wholesale trader brought many other wholesale traders with them. So
Okay.
yeah,
So actually, I have another question. Sorry,
no problem.
but if none of you is wants to ask a question, I will proceed. Actually, you seem to be like the $1 billion guy on this project. What was your actual function and job task? Because you seem to be a product owner as well as the tech lead, as well as
Yes.
the.
Yes, and so because I was the first engineer, it was everything was like nothing was decided. So it was learning about the product, learning about the like making the tech, hiring people, and by the end of it, I was into product, into tech, into also actually lifting stuff and shipping it from the wholesale trader to the retail shop owner. So I actually went on those journeys to ship those products. And finally, by the time I left, and I left because I had to come back to the US. So by the time I left, we had a team of around 30 engineers. And we had a separate team of people that curated just the images to make it localized. We had shipment team, we had other teams as well. So it was a mix of things, but yes, I